A dangerous asteroid is heading towards Earth. It's the size of the Empire State Building, and it's traveling at 16,000 miles an hour. It's called Apophis, after the Egyptian god of chaos. It will fly close to us in 2029. It won't hit us this time, but when it returns in 2068, that could be another story. If it blows up over a city, millions of people will die.
This could be the most devastating single event in U.S. history.
Earth is stuck in the crosshairs of a potential asteroid strike. Apophis is one of around 2,000 potentially hazardous asteroids that present a real and present danger. Asteroids have hit us before, and they will hit us again.
As far as cosmic dangers go, they're number one on the list.
This is not a drill. If we do nothing, this is our future. December 2018. The U.S. military detect a huge explosion in the Earth's atmosphere, high over the Bering Sea, off the coast of Alaska.
When an explosion of this magnitude is detected, everyone's mind goes to the same thing, nukes. But when the real answer was found, and it was determined that it didn't even originate from Earth, that was even more shocking.
The cause of the blast? An asteroid.
This asteroid was 30 feet across, something like that, over 1,000 tons. But it was moving at 20 miles per second, over 70,000 miles an hour.
This asteroid was small, and it exploded in the atmosphere over the ocean, so nobody was hurt.
But if it had been bigger, or it had come in over a different place, or it had been moving a lot faster, this could have been a dangerous object. But the scariest thing about it is that we didn't see it coming.
So far, we've been lucky. But near misses happen all the time.
About once a year, we get something the equivalent of a nuclear bomb going off in our atmosphere. And while that sounds horrible, most of these happen tens of miles up over open ocean where we go on completely oblivious.
We may be oblivious to most of the threats from space, but they are very real. We're going to get hit.
Over a certain amount of time, an asteroid impact is inevitable. It will happen, 100% absolute certainty.
NASA considers the threat from the skies so severe, it has made protection from asteroids a top priority.
These events are not rare. They happen. And of course, it's up to us to make sure that we are detecting and characterizing, tracking all of the near-Earth objects that potentially could be a threat. This is not about Hollywood. It's not about movies. This is about ultimately protecting the only planet we know right now to host life, and that is the planet Earth.
To help plan protecting our home, we carry out Earth defense simulations. For 3 days, 200 scientists at the Planetary Defense Conference battle a simulated asteroid 20 times larger than the Bering Sea space rock.
We practice, all right, what if this hits a major city? What would we need to do?
By running potential impact scenarios, we can prepare for a real asteroid strike.
This is like a fire drill that you would do at school or at work, where you practice and think about, okay, what if? Where are the exits? How do I get out? How fast do I get out?
The drill starts with the discovery of a simulated Earthbound asteroid.
So the first information is there's a big asteroid coming towards the Earth. Then we get a better estimate of how big it is, how fast it's going, and where it's going to hit.
The asteroid is heading straight for Earth, with Denver, Colorado in its sights. The Planetary Defense scientists send up a simulated spacecraft to smash into the asteroid and push it off its path. But it's a big gamble.
You can push it the wrong way. You can potentially have unintended consequences.
In the simulation, the spacecraft strikes the asteroid, deflecting it away from Earth. But the impact dislodges a 200-foot chunk, which is now heading straight towards the eastern seaboard.
So there's this one last piece that is now going to hit New York. We know that something that size is going to have citywide consequences. That is huge. That's a horrible impact.
When you're actually in the conference room and you understand eventually that New York City is going to be destroyed, and you're having strategies about how to evacuate people, all the timing, when you're doing the simulation, you're in your head, you're thinking about these things, you're trying to reason them out. But can you imagine the feeling in your gut, right, in your heart, if this was real?
If this were real, the chunk of asteroid would strike Earth's atmosphere at 43,000 miles an hour. As the space rock hurtles down, it collides with molecules in the atmosphere, which buffet the falling rock.
It's kind of like doing a belly flop into a pool, right? You're going from the vacuum of space into the dense lower atmosphere in mere seconds. And that's an incredible amount of pressure to put on the object.
The asteroid slams into the air ahead of it, compressing it violently. The surface of the asteroid gets hotter and brighter.
It's actually the air itself that's glowing luminously from the heating of the shock wave, the world's most intense sonic boom, if you will, that heats the air to incandescence as the object passes through. So that's the source of that brilliant illumination.
This bright burning asteroid is called a bolide. We witnessed one descending over the Russian city of Chelyabinsk in 2013.
All of a sudden, there was a huge fireball streaking through the sky, and people had no idea what they were witnessing because it looked like the sky was on fire. It was insanity.
As the asteroid descends, the compression of the denser air beneath it starts to flatten and even disrupt the falling rock.
There's a high pressure on the front, there's no pressure on the back, and it's being superheated.
And that intense temperature causes the air to glow, which is how we see the streak of a meteor. And it also disintegrates the asteroid itself. It's hot enough to literally melt rock.
This can often lead to them exploding.
The combination of heat and pressure invade the falling asteroid, causing it to blow up.
Most asteroids don't reach the ground before they completely disintegrate in a tremendous release of energy.
This is what we call an airburst, and we learned a lot about these while we were testing nuclear weapons after World War II. Some of these bombs were blown up underground and on the ground, but they found out when they blew up bombs above the ground, it actually did more damage. It was more widespread damage.
The explosion of the Chelyabinsk asteroid sent out a powerful shock wave at thousands of miles an hour. The blast traveled over 100 miles. It damaged 7,000 buildings and put 1,500 people in the hospital.
All of the injuries pretty much came from people who saw, oh, what's that bright flash in the sky? And they came close to a window to look and see what it was, and then the pressure wave hit and blew glass in their face.
The Chelyabinsk asteroid was only 65 feet across. The rock in the defense simulation is 3 times more massive, and it's heading straight for New York City.
Imagine what would happen if an explosion 1,000 times greater than that over Hiroshima hit New York. We're talking about an utter, complete destruction of the city and millions of people.
With so little warning, the only option would be to evacuate New York City.
How do we get everybody out of New York City within just a few days? That's where panic sets in. That's where fear would really become the dominant emotion.
Anyone left in New York City would see the boli racing in, followed by a blinding light as the asteroid explodes above the city. The blast would be equivalent to the largest nuclear weapon ever detonated on Earth.
Buildings would be flattened, melted. There would be fires for miles around. In the first moments of the explosion, 1 million people could be killed instantly, and many more would die later in the rubble and the ruins of what would happen there.
Everything within 9 miles of the blast epicenter would be completely destroyed. The intense heat and pressure would wreck buildings.
It's the worst possible day for New Yorkers. And not just the city itself, there's something like 15 million people living in the New York area.
The shockwave would race out over 250 square miles.
This would certainly be the worst disaster that the U.S. has ever experienced. We're talking about millions and millions of people displaced, affected within an instant.
This scenario is just a simulation for now. The asteroid Apophis is heading our way. If it hits Earth, it might not just kill a city. It could kill a whole region.
I wouldn't exactly want to be there when that happens. I want to be very, very far away.
Apophis will skim Earth in 2029. But its path could change, possibly turning a future miss into a direct hit.
From the network that brought you Dr. Pimple Popper, 2 new doctors. Unsock the shock. My feet are killing me. Series premiere tonight at 10 on TLC.
Across the country, schools are having to cut sports. I'm Tony the Tiger, and I'm on a mission to fix that. Buy a box and help all kids be tigers.
I switched to Miralax for my constipation. Stimulant laxatives forcefully stimulate the nerves in your colon. Miralax works with the water in your body to unblock your system naturally, and it doesn't cause bloating, cramping, gas, or sudden urgency. Miralax. Look for the pink cap.
This is Elvenar, a mystical world waiting for you to build your own unique city. Invite ancient friends, the dwarves, fairies, and orcs, to ensure growth, wealth, and peace for your new home. Elvenar, available in the App Store and at elvenar.tv. Play now for free.
I'm your mother-in-law. And I like to question your every move. Like this left turn.
It's the next one.
You always drive this slow.
How did you make someone I love?
That must be why you're always so late.
I do not speed, and that's saving me cash with DriveWise.
Yeah, my son, you did say that you were the safe option.
And that's the nicest thing you've ever said to me.
So get Allstate.
Stop bossing.
Where good drivers save 40% for avoiding mayhem like me. It's my son's favorite color. You should try it. You always drive like an old lady.
You're an old lady.
He's coming!
Okay, he's coming. Here he goes.
Where's Tiara? I got this for you.
When you grant a child's wish, you change lives. You can choose Make-A-Wish to get $250 from Subaru when you get a new Subaru.
Get 0.9% during the Subaru Share the Love event.
Here we go, come on. The world is nice to me, so get next to me, and we'll be feeling so fine.
Let's face it, this isn't Sling TV. With so many on-demand movies, shows, there's a lot more exciting stuff to watch at home. Let's ditch this kung fu.
Get the #1 live TV streaming service for less at Sling.com. From the time you're born, a gland in your brain produces growth hormone. It's what makes you stay lean, build strong muscles, and feel energetic. Unfortunately, around the age of 20, your body starts producing less GH. And by the time you're in your 40s and 50s, it's much harder to stay energetic, lean, and build muscle. But what if there was a way to tell your body to get back to work and boost your GH levels again? Nugenix GH Boost uses an amino acid and botanical blend, clinically demonstrated to help your body boost its own GH levels more than 100%. Text LOYAL to 42424 to get your complimentary sample of Nugenix GH Boost. And because most GH is produced while you sleep, GH Boost is specially formulated to help you get a deeper, more restful sleep. You'll get the boost you need to sculpt a stronger, leaner body that is sure to turn heads. Get back to work with Nugenix GH Boost. Text LOYAL to 42424 to get a complimentary sample of Nugenix GH Boost. Text LOYAL to 42424. That brought you Dr. Pimple Popper. 2 new doctors. Unsock the shock. My feet are killing me. Series premiere tonight at 10 on TLC.
April 13th, 2029. A speck of light races towards the Earth. It's an 1,100-foot wide asteroid called Apophis. We are about to have an extremely close shave.
It's the closest approach of any asteroid that didn't actually hit us for a long, long time. It will be 10 times closer than the moon itself. It'll be so close, it'll be brighter than some stars.
The football stadium-sized Apophis will race over the Atlantic.
If it were sitting on the surface of the Earth, it would weigh about 50 million tons, something like that. And that is not the place you want it to be. You want it to be in space and far away.
When we discovered Apophis in 2004, we thought it might be on a collision course with Earth, with a potential impact greater than the largest atomic bomb ever exploded.
The largest nuclear device, atomic device ever detonated on our planet was the Tsar Bomba bomb in Russia. So something like 55 or 56 megatons. When Krakatoa exploded in 1883, that was something like 200 megatons. Apophis impact would be 450 megatons. If something like that were to happen over New York City or Washington, D.C., you're going to lose the city.
The impact would be at least 10 times greater than the simulated asteroid strike on New York.
When you put it in those terms, that's just plain scary.
In a word, an impact from an Apophis-sized asteroid would be bad. Very, very bad.
Apophis's orbit will cross Earth every 7 years this century. It won't hit us in 2029, but this close encounter could change Apophis's orbit.
When a small asteroid encounters a bigger body like a planet, it's like a bunch of roller derby players. most of them are clumped together, but maybe there's one just on their own particular orbit. And as they circle around, as they get close to that larger clump, there'll be some interactions, potentially violent interactions, that will change the future trajectory of that lone roller derby skater. And the next time around, it might be a wide miss, or it might be a head-on impact.
It's the same in the solar system. The combined gravity of the Earth and Moon creates what's called a gravitational keyhole, a gravitational sweet spot, which could change Apophis's orbit.
That will change the potential future trajectory of this rock and might make it totally harmless, or might increase the chances of an impact even further in the future.
Because of the gravitational keyhole, there's still a small chance that Apophis will hit Earth in 2068.
That is the important lesson that Apophis taught us. You can miss the Earth, but if you pass through one of these keyholes at some time later, you will hit the Earth.
We now know Apophis will miss the keyhole in 2029, but there are other keyholes and other close passes. Apophis is not a lone threat. There are an estimated 832,500 asteroids orbiting the Sun.
Most asteroids live their lives perfectly peacefully past the orbit of Mars or trailing Jupiter and don't mind anybody else and don't cause any troubles. But some asteroids are on very particular orbits that cross the orbit of the Earth.
These asteroids have left the stable orbit of the asteroid belt and moved into orbits that get near our own. These asteroids are called near-Earth asteroids, or NEAs for short.
The near-Earth asteroid population is interesting and potentially dangerous because they're the ones that actually cross the orbit of the Earth. So they're most likely to have, at some point in the future, an impact with the Earth.
Most NEAs pose little or no threat to Earth, but we've detected over 2,000, including the 1,200-foot Apophis, that do. These are called PHAs, potentially hazardous asteroids.
The difference between a near-Earth asteroid and a potentially hazardous asteroid is distance and size. Anything can get near the Earth, and that could be 20 million miles away, something like that, and be a near-Earth asteroid. But a potentially hazardous one can hit us, and it's big enough to do damage. So something that over the next 100 years or so has a chance of hitting us and doing damage when it does, that's a potentially hazardous object.
PHAs are asteroids that are 460 feet or larger that could collide with Earth.
Take a 400-foot asteroid. If it hits, it would release as much energy as 3,000 Hiroshima nuclear bombs.
In July of 2018, NASA published a map of all the known NEAs and PHAs. The animation tracks their discovery from 1999 through 2018.
Every time I look at this animation, it does make my heart stop a little bit because it looks like we're in the middle of this swarm of angry bees circling all around us.
In 1999, we'd identified under 300 NEAs scattered through the inner solar system. 10 years later, we'd found 500 more. By 2018, we discovered 18,000 near-Earth asteroids, but we estimate there are millions out there.
It seems like we can never find all the asteroids. They just keep coming. It's like we're fighting an army of zombies.
Zombies that keep hurtling our way, hitting the Earth at up to 64,000 miles an hour.
That is very, very fast. That is much faster than a rifle bullet. And that's the key to its destructive power.
When a really fast and really large asteroid hits, the impact is off the charts. The blast is so intense, it can melt or even vaporize rock.
This year, your new Amazon device and the Food Network Kitchen app make cooking amazing.
Alexa, show me cooking classes with Bobby Flay.
Cook step by step and get the most out of your kitchen.
Perfection.
Download the app or enable the skill and cook smarter and faster in the new year.
Introducing the Food Network Kitchen app. This is the tip zone. Step-by-step interactive classes that will help you cook smarter and faster. You have got to get this app. Food Network Kitchen. Download the app and sign up today.
January 2019, a total eclipse of the moon. Astronomers train their telescopes on the darkening lunar surface. They capture a bright flash that lasts around a quarter of a second.
It was recorded. There were a lot of live webcasts and things like that going on at the time. And you can see this flash of light.
What the heck was that?
At first, the cause of the flash was a mystery.
It turns out it was actually a meteorite hitting the surface of the moon. And because it was dark, and because we were all looking at it, we could actually see it.
The moon's dark surface gave us a unique view of what happens when an asteroid strikes.
What was so exciting about being able to see this impact on the moon in a dark area is that we could actually look at the light that it produced and then back calculate exactly what the size of the impactor was.
We worked out that the impacting asteroid was just 20 inches wide. The crater it blew out was 45 feet across. How can something so small be so destructive?
The two things that matter the most are how fast it's going and how massive is the thing. The more massive, the bigger the boom. The faster, the bigger the boom.
Speed and weight are two very important factors to assess how much damage an asteroid will do. Just like a boxer, if a tiny person like me were to swing a punch, it would do a lot less damage than a heavyweight champion.
Same thing with asteroids. The bigger they are, the bigger the punch. But the same thing is fast, right? If I hit you really slowly, it's not going to hurt. I have to really wind back and pop. That's what happens with an asteroid.
The damage from an asteroid strike is determined by its kinetic energy. Kinetic energy depends on two things: speed and weight. Of the two, speed matters most.
If you double the mass, you double the kinetic energy. But if you double the velocity, you get 4 times the kinetic energy.
3 times the speed, 9 times the impact energy.
10 times as fast, it has 100 times the energy. So the velocity is what's really critical here.
The lunar asteroid weighed only 100 pounds, but it was traveling at 38,000 miles an hour, carrying a huge kinetic energy, which gouged out the crater. It's the same principle for impacts on Earth. 50,000 years ago, a 150-foot asteroid hit what is now Arizona. The impact blasted out an impressive hole, now called Barringer Crater.
It's about 3/4 of a mile across, over 500 feet deep. You could put the Washington Monument in the bottom of the crater, and the top of the monument wouldn't quite clear the rim. It's a pretty impressive hole in the ground.
In 2016, impact specialist Kathy Plesko visited Barringer Crater to see firsthand what mass and speed due to the surface of the Earth.
This is awe-inspiring to stand on the rim of a crater like this, understanding just how much energy it must have taken to excavate this much rock. Asteroid came in at about 27,000 miles an hour. It comes slamming into the surface and just explodes. Anywhere nearby here would have seen winds of thousands of miles an hour as the shockwave came out.
The immense power of an asteroid impact comes from the kinetic energy being transferred from the space rock into the surface rock.
It's an extremely violent process, and it starts with the moment of contact of the projectile with the surface itself.
It pushes into the crust, and at first it's just almost punching like sticking your thumb into dough. It's only about as wide as the object is. It's going straight down in, but then it's meeting resistance from the surface of the Earth. And so it squishes until it runs out of momentum. But then it's very compressed, and all of that energy is in a very small space. As it releases, it detonates like a bomb, and that's what makes the impact crater.
Simulations of an asteroid strike in the lab reveal the impact in slow motion. As the high-speed pellet hits the surface, the sand compresses downwards, then rebounds.
And as that rebound is occurring, that's when the material is being ejected out of the crater itself. You'll see the surface erupting outwards like the blooming petals of some big rocky flower as all this debris goes spraying out in every direction.
The 150-foot Barringer asteroid turned the rock to powder. 66 million years ago, an asteroid around 200 times larger and moving 1.5 times faster than Barringer hit Earth. This asteroid impact, called KPG, had so much energy, it turned rock to liquid.
This thing was immense. It's really hard to wrap your head around just how big it is. When it hits the back end of it is so far back that it's where a modern jetliner would fly.
The KPG asteroid hit the ground with a lethal combination of mass and speed. 1 trillion tons, traveling at 45,000 miles an hour.
Some rock is completely vaporized. It just becomes a gas. You have some rock that is melted. You have some that's thrown out into space.
This material goes up through that and then falls down and settles down over a huge area. That might be dust, it might be pulverized rock, it might be vaporized metal. It's all of this hot material raining down everywhere.
Some of the rock exploded skywards, but rock below the surface was slammed by a shock wave that was completely off the charts. Rock stopped behaving like rock.
We experience rocks as solid objects, but if you hit a rock hard enough, it flows like water.
The KPG asteroid hit so hard